Today our new method will be solving using elimination. The elimination method is a method in which you either add, possibly, if it lets me type, add or subtract the two equations to eliminate, that's why it's called elimination, one variable. And I'm not sure why it went all the way down. There we go. Alright, so the first example that we're going to be looking at here has 5x minus 6y equals negative 32 and 3x plus 6y equals 48. The first thing you'll want to do is to rewrite them where they are stacked vertically. And then you look to see if they have a common term. A common term means that they have the same coefficient with the same variable. So in this case, 6y and a negative 6y are common terms because they both have a 6 and they both have a y. If they both have a common term in them, then you can go ahead and decide if you need to add or subtract. In order to decide if you add or subtract, you need the common terms to go to 0. So negative 6y and 6y, in order to get those to go to 0, I would add. Because negative 6 plus 6 is 0. So then I go ahead and I add the rest of the terms. 5x plus 3x is 8x equals negative 32 plus 48, which gives me 16. And now, if I noticed, it eliminated my y, so I can solve for x. I divide both sides by 8, and I end up with x equals 2. Once you have solved for one variable, you need to sub that into one of the original equations and solve for the second one. I'm just going to go ahead and I'm going to choose to sub it into this equation over here. Again, you could sub it into any of the original equations. So 3 times x, but we know x is now 2, plus 6y equals 48. I now only have one equation, so I can solve that one equation for y. So 3 times 2 is 6, plus 6y equals 48. And I can solve that equation for y. So the opposite of plus 6 is to subtract 6 on both sides. We end up with 6y equals 42. Divide both sides by 6. And we end up with the solution that y equals 7. So our solution to our original system is the ordered pair of 2, 7. So don't forget to write your final answer as an ordered pair. The next one is a story problem. It says, suppose your community center sells a total of 292 tickets for a basketball game. An adult ticket costs $3 and a student ticket costs $1. The sponsors collect $470 in ticket sales. Write and solve a system to find the number of each type of tickets sold. Well, since it says I'm writing a system, that means I'm going to have two equations in this chapter. First of all, they sell a total of 292 tickets. There are two different types of tickets. I have the adult tickets plus the student tickets, and that total is going to be 292 tickets sold. So that's my first equation. The second equation deals with the money. It is $3 for each adult ticket and $1 for each student ticket, and I sell $470 worth. Again, you need to look to see if there is a common term. If I look at these, my common term is here. I have 1s and 1s. Once I know I have a common term, I decide if I'm going to add or subtract. I need 1s and 1s to cancel out and go to 0. Well, 1s minus 1s is 0, so that means I need to subtract all my terms. 1a minus 3a is negative 2a, is equal to 292 minus 470, which gives me a negative 178. I now need to divide both of them by negative 2, and I end up with a is equal to 89. I now need to sub that into one of the original equations. I'm going to sub it into this top one here, right here. And I need to solve for s. So if I sub that in, a is 89 plus s is equal to 292. I subtract 89 from both sides, and I get S is equal to 203. And now I can write my statement. So the adult tickets is equal to 89, and the student tickets, not quite a statement, but I'm just kind of shoving it in here, so is 203. As long as I can make sure I know what number represents what type of ticket. The next one makes it a little bit harder because if we notice, once we stack them, they do not have common terms. So I'm going to go ahead and look here. I'm going to go ahead and stack them, and I have 10x plus 3y equals 22. Remember, the common term means it has the same coefficient and same variable. So I have x's, but I have a 2 and a 10. That's not the same. My y's have a 5 and a 3, so those are not the same. But I know I could take 2 times 5 and make it a 10. So I'm going to rewrite that first equation and multiply everything in it times 5. 5 times 2x is 10x. And the reason I chose 5 is because now I have a common term of 10x. 5 times 5y is 25y is equal to 5 times negative 22, which gives me negative 110. Now that I have my common term, I can decide if I'm going to add or subtract. So here's my common term. 10x minus 10x goes to 0. 3y minus 25y is negative 22y. Is equal to 22 minus negative 110, which is 132. I now need to divide both sides by negative 22. And I end up with the fact that y is equal to negative 6. I'm going to sub that in. I'm just going to go ahead and sub it into this original one. I'm subbing it in for y. So I have 10x plus 3 times y, which I know now is negative 6, is equal to 22. 10x minus 18 equals 22. I'm going to add 18 to both sides. And I end up with 10x equals 40. Divide both sides by 10. And I end up with x equals 4. Do not forget, I need to write it in an ordered pair, x, y. So the answer to my system here is the ordered pair 4, negative 6. Okay, in this example, I only had to multiply one equation times something. On the next one, I have to multiply both equations times something. So if I go ahead and I stack these so that I can see them all lined up, my x's are lined up, my y's are. They do not have common terms. I cannot make a 4 times anything give me 7, and 2 times nothing gives me 3. So what I'm going to do is I'm going to try to get common terms as my y, and I just randomly chose the y. And the reason is because if I take this times 3 and this one times 2, I can get a common term. So when I multiply those, I end up with 12x plus 6y equals 42. And the bottom one times 2 is 14x minus 6y equals negative 16. If I look here, my common term is now my 6y. 6y blank, negative 6y, so I add to make them go to 0. 12x plus 14x is 26x is equal to 42 minus 16 gives me 26. Divide both sides by 26, and I get x equals 1. Again, you can sub that into any of the originals. I'm going to sub it into this one over here because it has smaller numbers and no negatives. So 4 times 1 is 4, plus 2y equals 14. I minus 4 from both sides. 2y equals 10. Divide both sides by 2. And I end up with y equals 5. As an ordered pair, then, my solution to this system is 1, 5. If you turn your page over, you have your quick checks, and then look at your schedule to find your assignment.